Today we have a very nice exponential equation. T raised to t equals 49. We need to solve for t. The first thing that comes to mind is that 49 can be written as 7 squared. But if you look at the equation, we have t to the t, and this is not of the form t to the t, so the answer is completely different and not what you think. First, note that t to the t is an increasing function. Check its plot. Also, we know that 3 raised to 3 is 27, and 4 raised to 4 is 64, so we can be sure that the value of t lies somewhere between 3 and 4. Now, if we draw a horizontal line that goes from y equals 49, we see that it intersects t to the t at exactly 1 point, so we have only one real solution to t. Now, let us try to solve it using algebra. First, let us apply the natural logarithm on both sides. Some people call natural logarithm as ln, but I will call it as log. This gives us log of t raised to t equals log of 49. Now, using the power rule of logarithms, we can rewrite this as t times log of t equals log of 49. In order to solve it further, we will use the Lambert W function. Suppose we have an expression like a times e raised to the power of a. When we apply the Lambert W function to this expression, we get the result as a. This is the beauty of the Lambert W function. Suppose, for example, we have the expression 3 times e raised to the power of 3. You can see that this is of the form a times e raised to the power of a, and the value of a here is 3. So now, if we apply the Lambert W function on this expression, we get the result as 3. Now we will use it in this expression. If you look closely, you do not have e in this expression, so we will have to convert this expression in terms of e. This is simple, as we can write t as e raised to the natural log of t, and this times log of t equals log of 49. We can change the order and write it like this also, as it is a simple multiplication. Now, if you compare this expression with the earlier one, we have the value of a as the log of t. So we can easily apply the Lambert W function on both sides of this expression. This gives w of log t times e raised to the log of t equals w of natural log of 49. What will be the value of this function? This value will be the same as a, which will be the log of t itself, and this will be equal to w of log of 49. Now, do not be scared about this right-hand side. This log of 49 is a constant, and this is also a constant. Now, we do not need the log of t, but we need the value of t. So, to solve it further, we will create the base of e on both sides. This will give us e raised to the log of t equals e raised to w of log of 49. Now, e raised to the log of t is t, and this is our right-hand side. Again, do not be scared of this term, as this was a constant, so e raised to this term is also simply a constant. You can leave the answer like this, or, if you want the value, we get this value as approximately 3.278. Oh, look, as we discussed earlier, our answer lies between 3 and 4. Also, this is the only real solution to this question. Isn't this super cool?